All right, just some important notes here. It is important to note that correlation is not causation. Just because there's a strong statistical relation between two variables, it does not mean that X causes Y. They both might be caused by something completely different. There's an old story about a king who learned that the province that had the largest amount of illness, was also the province in his kingdom that had the greatest amount of doctors. And therefore, what he decided to do was kill all the doctors because obviously they were causing the illness. Here's some examples of some articles that I found. Here's an example, an article, Smoking During Pregnancy Fosters Aggression in Children. And this is a study. Women who smoke during pregnancy risk delivering aggressive kids, while previous studies have shown that smoking during gestation causes low birth rate. This research shows that mothers who light up during pregnancy can predispose their offspring to additional risk, violent behavior. Now, this is what's typically known as an observational study. These researchers saw a statistical relationship between smoking during pregnancy and aggressive behavior in children. But that doesn't necessarily mean that that causes it. It could be caused, maybe some other factor is causing both aggressive behavior in children and smoking. For example, maybe the mothers are younger and they smoke. Maybe they're poor mothers or single mothers or poor parenting that's causing both smoking during pregnancy and aggressive behavior in children. Another study here showed that infants living in homes with two or more pets are less likely than other kids to develop allergies. The study concluded that early exposure to pets provides protection against allergies. Can you think of any other explanations? Well, it once again, maybe the fact that these parents were allergy free caused them to own pets and have allergy free kids. Um, doesn't necessarily mean that owning pets will cause allergy. They might be caused by something else. One final study here. People who smoke as teenagers are more likely to suffer from depression as young adults. This study made national headlines as evidence that teenage smoking causes depression. Can you think of another explanation? Well, how do we know that the depression isn't causing the smoking? People self-medicate with nicotine. That's the problem with the statistical relationships. You don't know if something is caused by something else or whether the flip side is true. People want to use this as evidence for one thing, but we can't necessarily conclude that. One final note here. Perhaps I'm looking at a variable that would be graphed like this. If I take the outside high temperature for the day and the number of absences from school, I might get a distribution that looks like this. When the outside high temperature is low, I get a lot of absences because of illness. And when the outside high temperature is high, like in May and June, I get a lot of absences because of people playing hooky or being inexcused. If I drew a regression line for this problem, I would probably get something that went straight across, and I would get b is equal to 0, indicating no relationship. But it wouldn't be no relationship, it would be no linear relationship. The actual relationship between these two variables would follow probably a curvilinear or a parabola. What I wanted to say is in this chapter we're looking exclusively at linear relationships, but actually variables could have relationships that are not linear. There could be other functions that would cause that.